Look up at the night sky. You see stars, planets, and distant galaxies, right? It looks like a vast empty void where things just happen to be floating around. But what if I told you that everything you see is actually just the glitter on a massive, invisible spiderweb? We've spent decades thinking space was mostly empty, but we were wrong. There is a colossal hidden structure dictating where every single star lives, and we are finally starting to see the blueprint. Welcome to SciNova. Today, we are venturing beyond the visible light to explore the impossible cosmic web. For a long time, astronomers were puzzled by why galaxies aren't just scattered randomly like salt spilled on a table. Instead, they seem to huddle together in specific spots, connected by long, thin bridges. The culprit? Dark matter. It's the invisible scaffolding of the universe, and it's much more organized and much stranger than we ever imagined. To understand this, we have to talk about the cosmic traffic jam. Imagine a city where all the cars are stuck on specific highways, leaving the fields and forests in between completely empty. That is exactly how the universe works. Galaxies aren't just drifting, they're trapped in massive cosmic filaments. These filaments act as bridges of hot gas and dark matter that connect galaxy clusters across the unimaginable distances of the deep cosmos. These filaments aren't just small bridges either. They are absolute behemoths. Some of these structures are so massive that a single filament can be 10 times as massive as our entire Milky Way galaxy. We aren't just talking about a little bit of extra gravity. We are talking about a structural backbone that holds the entire architecture of the universe together. Without this dark matter scaffolding, gravity wouldn't have been able to pull matter together to form the stars we see today. But how do we know this if dark matter is, by definition, invisible? This is where the James Webb Space Telescope comes in. JWST has changed the game entirely. It has provided unprecedented high-detail mapping of the cosmic web, allowing us to trace these structures back to the universe's very first billion years. We aren't just guessing anymore. We are seeing the shadows and the gravitational footprints left behind by this invisible web. The data coming back from JWST is actually throwing a massive wrench into our existing models. We used to think dark matter was cold, meaning it moved slowly and clumped together easily. However, observations of elongated early galaxies captured by JWST suggest that dark matter might not be cold at all. This could point toward something much more exotic, like ultralight axion particles or a warm dark matter composition that behaves differently than we predicted. If dark matter is made of these strange axion particles, it changes everything about how the universe grew. It means the scaffolding isn't just a rigid structure, but something more fluid and wave-like. This isn't just a minor detail, it's a fundamental shift in how we understand the very fabric of reality. We are moving from a universe of simple particles to a universe of complex, quantum-like structures on a cosmic scale. And the discoveries aren't slowing down. Astronomers have recently detected a massive, rotating cosmic filament structure that is absolutely staggering. This isn't just a static bridge. It's a structure spanning approximately 50 million light-years that appears to be spinning in the void. Think about that scale for a second. A structure so large, it defies our traditional understanding of how cosmic structures move and evolve. A 50 million light-year-long rotating filament? That sounds like science fiction, but the math checks out. This discovery suggests that the cosmic web isn't just a passive skeleton, but a dynamic moving system. It's as if the universe has its own internal currents, much like the oceans on Earth, but on a scale so vast that the waves take millions of years to move even a fraction of the distance. This brings us to a massive realization currently being debated in the scientific community. At the upcoming ICRC 2025, researchers are expected to present 78 different dark matter contributions, showing just how much we still don't know. We are entering a golden age of cosmology, where the very definition of matter is being rewritten. The more we map the web, the more we realize that the visible universe is just the tip of the iceberg. So let's recap the cosmic picture. We have galaxies that look like they are floating, but they are actually stuck in a giant, invisible traffic jam. We have filaments that are 10 times more massive than our galaxy, acting as bridges across the void. And we have a rotating 50 million light-year-long structure that proves the universe is far more active than we ever suspected. It's a complex, interconnected, and incredibly beautiful web. If we can truly master the map of this cosmic web, we might finally answer the biggest question of all. How did we get here? By understanding the scaffolding, we understand the growth of everything from the first atoms to the complex life on Earth. We are part of this web. We are part of this cosmic dance. The dark matter that shapes the galaxies also shaped the very path that led to our existence. The universe isn't empty, and it isn't random. It is a structured, organized, and deeply mysterious masterpiece of physics. As our telescopes get better and our math gets sharper, the invisible will become visible. We are finally pulling back the curtain on the greatest show in existence. The cosmic web is waiting to be fully understood, and we're just getting started. If you found this journey through the cosmic web fascinating, make sure to hit that subscribe button and turn on notifications. We are constantly exploring the frontiers of science here at SciNova, and you won't want to miss what we uncover next. Leave a comment below. Do you think dark matter is cold or something even weirder? Thanks for watching, and keep looking up.